Good morning children, welcome back to the chemistry session. In previous session, we have discussed about Heisenberg's uncertainty principle and dual nature of matter. In today's session, we are going to talk about quantum mechanical model of an atom. Let us start today's session children. Quantum mechanical model of an atom. The basic idea of quantum mechanics was developed independently in 1926 by Werner Heisenberg. Because in 1926, Werner Heisenberg stated that his principle, which was famously known as Heisenberg's uncertainty principle, which states that it is impossible to measure simultaneously the exact position and exact momentum of an electron at a given instant. And next, in 1927, Erwin Schrödinger explained the equation. That equation is called as Schrödinger wave equation. So these two theories were the horizon or basis of quantum mechanics or quantum mechanical model of an atom, because Bohr's atomic model was based on classical mechanics. Classical mechanics describes properties of macroscopic objects such as Newton's law of motions and planetary motion and falling objects. But coming to microscopic objects describes nature or behavior of subatomic particles such as electrons, protons and even atoms and molecules. Those are subatomic particles, and this quantum mechanics based on dual nature of matter, because Heisenberg's uncertainty principle as well as Erwin Schrödinger's theory followed dual nature of matter. That's why Schrödinger's wave equation and Heisenberg's uncertainty principle were the basics of quantum mechanics. Let us see Schrödinger wave equation children. Schrödinger wave equation, it simply can be written as Schrödinger wave equation of electron in 3 dimensions, such as dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square into e minus b into psi is equal to 0. This is Schrödinger's wave equation 3 dimensions, where dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square means this is double differentiated equation along x axis, y axis and z axis. Double differentiated equation along x, y, z coordinates. Here psi is probability amplitude. Psi is probability amplitude of wave function, and here x, y, z are coordinates, and m is mass of the particle. So we are talking about when radiation in motion, it possesses both particle and wave nature, that is dual nature of matter. Dual nature of matter possessed by the electron. That's why here m is mass of the particle, that means mass of the subatomic particle. Next, E is total energy of the particle. E is total energy of the particle. and V is potential energy. V is potential energy. And psi is, we have already discussed here, probability amplitude or wave function. Psi is probability amplitude or wave function. And H is Planck's constant. H is Planck's constant and H value is 6.625 into 10 to the power of minus 34 joule second. These are the terms present in Schrodinger's wave equation. This equation represents wave motion of electron along three axes such as x-axis, y-axis, z-axis in the space. And simply it can be written as H cap psi is equal to E psi. This is the simple notation or simple representation of Schrodinger's wave equation. H cap psi is equal to E psi, where H cap means Hamiltonian operator. H cap is Hamiltonian operator. And psi is probability amplitude or wave function and E is total energy of the particle. So it is the simplest notation or representation of Schrodinger's wave equation. So when we solve this Schrodinger wave equation, this Schrodinger wave equation describes three constants. Those constants are called quantum numbers. We will discuss later. Here, when we solve the Schrodinger wave equation for hydrogen atom, they noticed that different energy levels present in the hydrogen atom, and the solution of Schrodinger wave equation given for hydrogen atom is energy of the electron in hydrogen atom by using Schrodinger wave equation, which has given minus of 2 pi square m e power 4 by n square and h square. Minus of 2 pi square m e power 4 by n square h square. Remember children, the energy of the electron in hydrogen atom was solved by Schrodinger wave equation is similar to that of Niels Bohr equation, because Niels Bohr derived energy of an electron by using classical mechanics, that is equal to minus of 2 pi square m z square e power 4 by n square h square. Here we are talking about energy of electron hydrogen atom. That's why Z is equal to 1. Z is equal to 1, and we know the values. When we substitute the values like mass of electron, that is equal to 9.1 10 to the power minus 31 kilograms, and E charge of electron is minus 1.6 10 to the power of minus 19 coulombs, and H is Planck's constant. Its value is 6.625 10 to the power minus 34 joule second. When we substitute the values in the given equation, the value would be minus of 2.182 10 to the power of minus 18 joule per atom. Joule per atom by n square. Once observe both the equation which was derived by Niels Bohr. This is Bohr's equation from his atomic model. According to Bohr's equation, this is the energy of the electron in hydrogen atom. This was similar to that of Schrodinger's wave equation, because when we substitute the values of mass of electron, charge of electron, and Planck's constant, and we get the value. That means Bohr's atomic model was similar to that of the Schrodinger's wave equation. But Niels Bohr proposed orbits, stationary orbits around the nucleus. But according to quantum mechanics, the stationary orbits may not be hold good, because according to classical theory, according to Bohr's atomic model, Electrons revolve around the nucleus in circular paths. They are called orbits. When the electron moving in the stationary orbit, the position as well as velocity of the electron is certain. But according to Heisenberg's uncertainty principle, it is impossible to measure simultaneously the exact position as well as momentum of the electron at a given instant. That's why Bohr's model doesn't hold good for dual natural matter. That's why this Schrödinger wave equation and Heisenberg's uncertainty principle holds good for quantum mechanics. And when we solve the Schrödinger wave equation, the solution of the Schrödinger wave equation produce three constants. Those constants are called quantum numbers. Those quantum numbers are called denoted by L, M and M. N is called principal quantum number, L is experimental quantum number, M is magnetic quantum number. And this quantum mechanics proposed a word psi square, where psi square means probability density. Probability density. What do you mean by probability density? Probability density means there is a small space around the nucleus where maximum probability of finding of an electron in the space. That is called probability density. When the probability density psi square value is more, when psi square value is high, then we can find out or we can tell that more probability of finding of an electron is present in the space. Or if the psi square value is less probability of finding of an electron in the space. Or the psi square value is 0. Psi square value is 0 means 0 probability of finding of an electron in the space. Here psi square means probability density, which is also called as orbital. So orbital can be defined as orbital is the region of space around the nucleus where probability of finding of an electron is maximum. I am repeating, children. Orbital can be defined as the region of space, the smallest region of space around the nucleus where probability of finding of the electron is maximum. This smallest region of space is called orbital. So we can find maximum probability of electron in the orbital. So that Schrödinger wave equation or quantum mechanics define orbital. Niels Bohr atomic model define a word orbit. Orbit is circular path revolve around the nucleus. Orbit means orbit or stationary orbits was proposed by Niels Bohr. These orbits can be defined as these are circular paths revolving around the nucleus, and these orbits are denoted by K, L, M, N. And orbital can be defined as the smallest region of space around the nucleus where probability of finding of an electron is maximum. This is called an orbital. An orbital can be denoted by S, P, D, F, G, H and so on. S, P, D, F, G, H are the letters used to denote orbitals. So let us see the quantum number. Because if you want to express or if you want to denote exact position of an electron in the space as well as size of the atom and energy of the electron in the atom, we use three constants. Those constants are called quantum numbers. The solution of the Schrödinger wave equation gives out three constants. Those constants are called quantum numbers. Those quantum numbers describes exact position of an electron in the space. So those are called quantum numbers. So let us talk about quantum numbers today. Because, so I told you that psi square means probability density. According to quantum mechanics, probability density can be defined as where the maximum probability of finding of an electron in the space, in a space around the nucleus, where the maximum probability of finding of an electron is present, the smallest region of space is called orbital. So we can identify or we can find maximum probability of electron in the space in a smallest region. The smallest region is called orbital, children. This idea was given by quantum mechanics. This quantum mechanics was developed independently by Erwin Schrödinger and Werner Heisenberg. Because of the equation which I have given earlier, because of that equation, Erwin Schrödinger was awarded by Nobel Prize in Physics in the year 1933. And the solution of Schrödinger equation results 3 quantum numbers. These quantum numbers tells about exact position of electron in the space. These are principal quantum number, principal quantum number. What is the notation of principal quantum number? Principal quantum number is denoted by small n. Who described principal quantum number? Principal quantum number was discovered by Niels Bohr. Niels Bohr discovered principal quantum number. And what are the values of principal quantum number? Principal quantum number values are whole numbers. That is, values of n is equal to 1, 2, 3 and so on infinity. Because according to Bohr's theory, there are infinite number of circular orbits around the nucleus. So that n value starts from 1, 2, 3, so on, infinite number of values. And what information does principal quantum numbers gives? Principal quantum number tells about size of the atom and energy of the electron in the atom. Principal quantum number tells about size of the atom and energy of electron. Energy of electron in an atom. Because principal quantum number tells about principal energy levels or principal energy shells. Principal energy levels or principal energy shells also called as main shells. Principal quantum number small n, which tells about main shells or principal shells. What is the denotation of principal shells or main shells, which can be denoted by K, L, M, N and so on. What is the N value for K shell? N value is 1 for K shell, L shell 2, M shell 3, N shell 4 and so on. And as the number of shells increases, the size of the atom or the radius of the atom also increases, as well as energy of the electron also increases. When the electron is present in first energy level, its energy of the electron is less, because force of attraction between the nucleus and electron in the first orbit is more. When the force of attraction is more, energy of the electron is less. When the energy of the electron is increases, that means when the distance between the nucleus and shells increases, energy of the electron also increases, because the force of attraction between the nucleus and outermost electron, when it decreases, then electron gets more energy. Then the electron is free from the nucleus influence, then electron energy also increases when the radius of the atom increases. That's why energy is inversely proportional to the radius. Energy is sorry children, energy of the electron increases as the radius of the atom also increases. Energy is directly proportional to the radius children. Okay, and Niels Bohr also calculated maximum capacity of each principal shell. That means how many electrons can be accommodated in K shell. Here let us see the table from children. Here shell length, n value, and a maximum capacity. I have already given this table form in Bohr's atomic model. Once again, we will discuss here. Suppose first shell K shell, n value is 1 for K shell. N value 1, by using 2n square formula, maximum capacity of shell can be calculated by 2n square formula children. I already given in Bohr's atomic model. By 2n square formula we can find out maximum capacity. That means maximum number of electrons that can be present in a given shell. So 2n square. N value is 1 here. So 2 into 1 square is equal to 2. So capacity of a shell is 2 electrons. Next, second shell, L shell. N value is 2 for L shell. And capacity of L shell, 2 into 2 square is equal to 8. Next, M shell. N value is 3 for M shell. And capacity of M shell, 2 into 3 square is equal to 18. Next, N shell. N value is 4 for N shell. And capacity of N shell, 2 into 4 square is equal to 32. So by 2n square formula, we can find out number of electrons in a given principal shell. In K shell, we can accommodate 2 electrons. L shell, 8 electrons. M shell, 18 electrons. N shell, 32 electrons. So this information we can get from principal quantum number. Listen to me children. This principal quantum number was denoted by N, was proposed by Niels Bohr. Values of principal quantum number starts from 1 to infinity. And this principal quantum number tells about size of the atom and energy of the shell. Next, this principal quantum number tells about main shells or principal energy levels. Those are indicated by KLMN or 1, 2, 3, 4. And when the distance of the nucleus and the shells increases, radius increases as well as energy of the electron also increases. And Niels Bohr had given the formula, that is 2n square. By 2n square formula we can find out maximum capacity of each shell. So this is principal quantum number. Second one is the quantum number.